All right, AP Precalc, welcome back to part 2 of section 1.1. We're going to be focusing today on the features of graphs. All right, so we're going to start this lesson off by talking about when a function is positive versus negative. And a function is positive when its graph is above the x-axis, and then vice versa. A function is negative when its graph is below the x-axis. All right, so I pulled up a graph here on Desmos. We don't need to know the equation for this graph, but I am going to reference this graph for the rest of the lesson. So just to highlight a few key points, the first zero of this graph is at roughly negative 0.3. The second zero is at x equals 2, and the last zero is at x equals about 3.3. There's a turning point or a relative minimum down here at the bottom at 0.6. And we're just going to use the x coordinates from these. And there's another turning point or relative maximum at about 2.7. All right, so we're going to label now when this graph is positive versus negative. So again, positive means above the x-axis. So I'm going to go ahead and highlight here everywhere that this graph is positive. So this first section here in blue, that is above the x-axis, so the graph's positive there. And there's another section over here to the right that is also above the x-axis. Now, to list these as intervals, we're going to list the x-coordinates. So in this first blue interval over here, the coordinate point that the graph is approaching, it's going left forever. So the x-coordinate is getting closer to negative infinity. Even though it's going left slowly, it's still going left. And the y-coordinate is getting close to is positive infinity. Where this graph stops being 0 is the x-coordinate. Again, it was roughly negative 0.3. All right, and it's, again, just the x-coordinates we're going to use for these intervals here. Then the graph starts to be positive right after x equals 2. And at the last zero was at 3.3. All right, so to list the interval where this graph is positive, we're going to list the leftmost x of the first interval, which was that negative infinity, followed by the rightmost x of that interval, which was negative 0.3. The second interval, we're going to put a u here to show that there's two intervals. All right, then the second interval started at x equals 2, and it stopped at x equals about 3.3. So that would be those would be our two intervals, rather, where the function's positive. Now, when is this graph negative? Well, that's when it's below the x-axis. So I'm going to highlight that in pink here. So that would be this portion of the graph. And then down here would be our last portion of a graph. All right, so the intervals where this is negative, let's see, the first x-coordinate where it starts being negative is that negative 0.3. And then the end of that interval would be x equals 2. And this also has a second interval, so another u. And then it starts being negative at 3.3. And then the x-coordinate, be careful, this is moving right and down, but we want the x, which is the right. The coordinate point here that we care about is the positive infinity for the x. The y value is getting closer to negative infinity, but we care about the x value here. All right, so that's our answer. The second interval, again, is 3.3 to infinity. All right, so now we're going to switch gears and talk about when a function is increasing versus decreasing. Our first definition says this, that a function is increasing when the function's graph is moving right and up. All right, so we're going to look at the graph from left to right, not right to left, but left to right. If it's moving up, then the function's increasing. Also, as we're going from left to right, if the function is moving down, then that function would be decreasing over that interval. So we're going to take that same graph. Now we're going to apply the idea of increasing and decreasing to this graph. So I went ahead and kind of shaded the graph of when it's increasing and when it's decreasing. But again, you're doing this from left to right. So yes, the graph is moving left and up, but as we move to the right, this is decreasing in its first interval because the graph is moving down to the right. Then up to the right, it's increasing, and then down to the right again. All right, so to give our answer for when this function is increasing, it's going to start down here at that relative minimum, and then it's going to stop increasing up here at this relative maximum, which I wrote down those values earlier as 0.6 and 2.7. All right, that's the first interval or really the only interval where that graph is increasing. All right, decreasing, we have two intervals here. And again, these are the x-coordinates only. We're ignoring the y-coordinates. So for the first interval, again, from left to right, the leftmost x-coordinate is negative infinity. And the rightmost x-coordinate is that minimum, which was, again, 0.6. That's our first interval. Our second interval, the leftmost x-coordinate is 2.7. And the rightmost x-coordinate, even though it's moving down, the rightmost x-coordinate is positive infinity because it's headed to the right. All right, our last two definitions, we're going to compare something called concave up versus concave down. This is likely the first time you've ever heard this terminology. So it might take a little bit of time to master this one, but it says this, that a function is concave up when that function's rate of change or slope is increasing, and that a function is concave down when that function's rate of change or slope is decreasing. So let's look at a graph and see what this looks like. All right, so I went ahead and shaded on this graph when this graph is concave up and when it's concave down. So to the left of this point where it switches from blue to pink, to the left of that point, the graph is concave up simply because it looks like it's opening up. If a portion of the graph looks like it's opening up, that portion's concave up, and if it looks like it's opening down, then that portion's concave down. So to list when this graph is concave up, again, all we need to do are the x-coordinates. And so the x-coordinate where this starts being concave up from left to right, the leftmost x-coordinate is negative infinity, and the rightmost x-coordinate is about 1.5. And we don't know at this stage of the game exactly how to find that value. That we're just told where that point is where the graph will switch concavity. All right, lastly, this graph will be concave down, starting at that x-coordinate of 1.5, and the graph is going right forever, and so the x-coordinate at the end of our interval would be a positive infinity. All right, thanks so much for watching, guys. I hope it helped. Be sure to like and subscribe, and as always, stay flawless.